This is an excerpt from your notes that we did in class today. This is the notes for 1.4, solving a literal equation. So this is actually the second day that we have worked on this, but this was a little more formal. We actually sat down and took notes. So if you were still struggling, hopefully watching this video will kind of clarify some of the issues that you're having. So if you look here and you look on your notes, step 1 says to identify the variable you are trying to isolate. So if you look at the example that I have here, they're asking you to solve this literal equation for y. So I want to look and see where y is in the equation to start with so that I know how to use my inverse operations to move stuff away from it. So I see right here, this is 3 times y plus 4x equals 9. Okay? So then it tells me to use inverse operations or work backwards to move all constants and other variables to the other side of the equation. Okay, so let's look at that. So I'm going to rewrite my equation so that I have a little bit more room to work. So I've got 3y plus 4x equals 9. And I'm trying to get y by itself. So just like with regular equations, if possible, we want to try to do as least amount of steps as possible. So we have this plus 4x right here, and the opposite of adding 4x would be to subtract. So I'm going to subtract 4x from both sides in order to get y by itself. So positive 4x and negative 4x will make 0, and I bring down my 3y. And then this is the part that is different from solving equations. I can't actually subtract 9 minus 4x because they're not like terms. So when I write my expression on the right side over here, I'm actually writing 9 minus 4x. Okay? All right. Now from here, I notice that y is being multiplied by 3. So in order to undo that, I am going to divide by 3. My 3's will divide out to make 1y, and whatever I do on the left, I have to do on the right. Now here is kind of the part that's a little bit different. So notice that we have 9 minus 4x, and all of those terms are being divided by 3. So 9 is actually divisible by 3, but negative 4x is not. So what you want to think about is it's like 9 divided by 3 minus 4x divided by 3. If you think about it like that, then this next part should make sense. I am actually going to go ahead and divide 9 by 3. 9 divided by 3 is 3. Minus, and then over here, this next part, I'm just going to keep it as 4/3 x, or 4x over 3. Okay? And then at that point, you've done what you were after. You were trying to get y by itself according to this problem. So I know that y is equal to 3 minus 4/3 x. You might also see me write it with the 4/3 x first, because when we get to our linear unit, that's going to be more than likely how we see this. So just make sure that if you write the 4/3 x first, that you bring that sign with it. It is negative 4/3 x plus 3, or you can leave your answer like this for right now. Okay, so we worked several examples today in class, but I want to make sure that we go through a few here on the video, just in case you need some extra support. So let's look at the last section of your notes. Alright, so on this last section of your notes, we were actually solving these equations for x. So I'm going to look at number 4, and on number 4, notice we have y equals 5x minus 4x. Step 1 in our steps was to look for the variable that you're trying to isolate, and notice I have 5x's and minus 4x right here. So this is actually an easier type of equation because I need to combine like terms before I get started. So I know that I'm going to have y equals, and then what is 5x minus 4x? It's just 1x. So really, I didn't have any inverse operations that needed to occur because I've already isolated x. I know that in this one, y equals x, or if you like to look at it with x equals y, that is also correct. Okay, so now let's go ahead and look at number 5. It's a little more difficult. So on this problem, I'm going to go ahead and rewrite down here where I have a little more room to talk to you guys. We have 2x plus kx equals m. And we're still trying to solve for x. Only this problem is a little bit more tricky because they have 2 times x plus k times x equals m. And so I can't just combine like terms because 2x and kx, they're not like terms. They have to have the same variable or combination of variables in order to be considered alike. So somehow I need to get x isolated from both of these terms. So if you think about it, 2 times x plus k times x, well, they're both being multiplied by x. And we talked about the distributive property last week. So what if we undo the distributive property? Well, the inverse of distributing is called factoring. And when you factor, really all you're doing is dividing out an x and rewriting it as if the distribution hadn't occurred. So, since I can divide an x out of both of these terms, you are pulling that x back to the front like the multiplication hasn't happened yet, and you have x times 2 plus k equals m. So when we talked about this in class, we talked about the fact that really all we've done is undone distributing. Because if I was to put this x back in, you would multiply x times 2 and get 2x, and then x times k and get kx. So this is called factoring. And all we've done is undone that multiplication or that distribution that has occurred. Now I can get x by itself easily. What is happening here? Well, x is being multiplied times 2 plus k. And the opposite of multiplying is dividing. So I'm going to divide both sides times 2 plus k. When I do that, 2 plus k will cancel, and I'll be left with x equals m divided by 2 plus k, which was my goal. I got x all by itself. Okay, so number 6 is similar to number 5, so I want you guys to pause the video and see if you can work number 6, and then you can check your work with mine. Okay, so let's look at this problem. So there was one extra step that made it a little bit different than number 5, and that is that there was 3 plus 5x minus kx equals y. So, pardon me. So I've written my work down here. So the first thing that I wanted to do is go ahead and get rid of that 3. So the opposite of positive 3 was minus 3. Those canceled, and then I just brought down everything on the left, and that would be equal to y minus 3. Now it looks very similar to where we started on number 5. So notice 5 times x minus k times x equals y minus 3. So because x is being multiplied by both terms, I can undo the distribution by factoring. So I divided out that x and it went to the front, and then I have my binomial, which is 5 minus k. Okay? Then from here, to undo that multiplication that would occur, I divided both sides by 5 minus k. Those cancel on the left, and I have x all by itself, which was my goal. And then on the right, I have y minus 3 all over 5 minus k. Okay, so this was day 2 of solving literal equations. Hopefully you're getting a little bit more confident, or maybe you have it. But we're going to have another day of this, so I want to make sure you guys are prepared. If you have questions, please come in for tutoring. Don't wait, and I will see you guys tomorrow.